Hello students, today we are going to learn the third topic from standard 9th maths part 1, that is polynomials. Consider some algebraic expressions which involve variables and constant. So the first expression is x square minus 7x plus 1 by 5. Here the variable is x. Second is 7m minus 2n square. Third is root 2 y cube plus 9y. And 1 by x plus 6x square. So these are the some algebraic expressions which involves variable and constants, and they are joined together by plus or minus sign. So based on this we are going to learn what is a polynomial. So suppose there is a algebraic expression, and if the power of the variables are whole numbers, then that algebraic expression is known as a polynomial. Now if we consider the expressions given above, so the first equation we have x square minus 7x plus 1 by 5. Here the powers of the variable x are whole numbers. In the first term we have the power 2, in the second term it is 1. That's why this is a polynomial. For second case also there are two variables m and n. For both of these powers are whole numbers. For third equation also power of variable y are whole numbers. But for the next one, that is the fourth equation, we have 1 by x plus 6x square. So in this equation the power of the variable x in the first term is minus 1. So it is not a polynomial. So this is how we can define a polynomial, algebraic expression in which if the power of the variable involved is a whole number, then it is a polynomial. Then the next concept is constant polynomials. Suppose there are some numbers like 6, minus 2, 1 by 2, 0, root 3. As you can see here, no variable is involved. So these are the constant numbers. That's why all the constant numbers can be treated as a constant polynomials, as they do not have any of the variable. We can convert any of the constant term into a polynomial. Suppose for example if we take 6, which is a constant number, and it is a constant polynomial because we can convert this constant number into constant polynomial. See how it is. 6 into, we can write here x raised to 0. 6 into x raised to 0. Let us consider x as a variable here. So what will be there? 6 into x raised to 0, that means 6x raised to 0. As we know that x raised to 0, which means 1. So we can have again 6 into 1. We'll have the same constant number. That's why we can convert any of the constant number into polynomial. That's why any constant number is treated as a constant polynomial. Now we have some types of polynomial based on the terms that it involves. So there are three types basically: monomial, binomial and trinomial. As the name suggests, in the first type of polynomial, that is monomial, only one term is involved. That's why it is called as a monomial. So as we can see in the examples, 2x, it has only one term, that's 2x. So it is a monomial. 7, it is a constant polynomial. Again it has only one term. That's why it is a monomial. In binomial there are two terms. See in the first example, x raised to 5 plus x square. So it has two terms involving and they are joined together by a positive sign. That's why these two are binomials. And trinomial, which contains three terms in that polynomial. So for the first example, 1 by 2 y square plus 7y minus 11, as it contains three terms, it is called as a trinomial. Likewise, root 3x square plus x cube plus 2, it has also three terms. That's why it is called as a trinomial. Next concept is degree of a polynomial. Suppose there is a polynomial given, and if we find the highest power of the variable in that polynomial, then it is the degree of the polynomial. So suppose let us consider one example: 2x cube minus 5x plus 7x square plus 9. As it has 4 terms, and out of all these 4 terms, the degree of the variable x, the highest degree is 3 in the first term. That's why degree of this given polynomial is 3, as it is the highest power of all the terms that it contains. So this is degree of the polynomial. Now there are sometimes more than one variable in an equation. Then how to find the degree of that polynomial? So that is our the next point, degree of polynomial in more than one variable. Now for that one we have to take the highest sum of the powers of variables in each term of the polynomial, and that is called as degree of the polynomial. So let us consider one example. So in this equation there are three terms. The first term is 3m cube n raised to 4 plus 7m square n cube minus mn. In the first term there are two variables m and n, and their respective powers are 3 and 4. So we have to add them. 3 plus 4, that's 7. For the second term, again the variables are m and n. Their powers are 2 and 3. So we should add 2 and 3. It is 5. And for the third one, the power is 1 each. So 1 plus 1 is 2. So amongst all these three numbers, we have got 7 as the highest number. That is, the highest sum of powers of variables in the first term is 7, which is highest amongst all. That's why the degree of this given polynomial is 7. So this is how we can find the degree of the polynomial if there are more than one variable. Now the next point is types of polynomials based on the degree of that polynomial. So earlier we have made three types of polynomials based on the terms that it contains. Now this time we have to classify the polynomials based on degree of that polynomial. So there are three types: linear polynomial, quadratic polynomial, and cubic polynomial. So suppose there is a polynomial given and degree of that polynomial is 1. So that is here in, for example, 5x minus 4, it has the degree 1. And in second example also degree of the polynomial is 1. That's why these two are linear polynomials, as they have the degree 1. For these two types of polynomials, we have the degree, the highest power of the variable is 2 here. That's why its degree is 2. So these types of polynomials are called as quadratic polynomials, as they have degree 2. And if there is a degree of the polynomial is 3, so as we can see in this example, degree of the given polynomial is 3, as the highest power of x is 3. So this is called as a cubic polynomial. So based on the degree of the polynomial, there are three types: linear polynomial, quadratic polynomial, and a cubic polynomial. We can also have their standard forms. So for the linear polynomial, the standard form is ax plus b, where a and b are any two constant numbers, but only condition must be satisfied here that a must not be equal to 0. Because if a is equal to 0, it will not be a linear equation. That's why a must not be equal to 0. The standard form of quadratic polynomial is ax square plus bx plus c, where a, b, c are any constant numbers, any real numbers, and again condition must be that a must not be equal to 0. Because if we take a is equal to 0, then a 0 into x square, it will become 0, and we will have now bx plus c, which is again the linear polynomial. So at that time, if we take a is equal to 0, at that time this given equation will not be a quadratic, this polynomial will not be a quadratic polynomial. That's why a must not be equal to 0. Similarly, for cubic polynomial, the standard form is ax cube plus bx square plus cx plus d. Here again a, b, c, d are any real numbers, and a must not be equal to 0. So these are the standard forms of the linear polynomial, quadratic polynomial, and a cubic polynomial. Now from all these, let us have the standard form of any of the polynomial. So an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 up to a2x square plus a1x plus a0 is a polynomial in a variable x with degree n. Here an minus 1, an minus 2 up to a2, a1, a0 are all coefficients, and here one thing should be noted that an must not be equal to 0. Now consider, for example, x raised to 5 plus 3x square minus 7x plus 9. So this is the polynomial in variable x with degree 5, as it is the highest power of the variable x. Now if we have to represent this, we have to represent this like p of x. So it is denoted by p of x, as x is the variable. Now we have another example, m cube plus 2m minus 15. So it is also represented, it can be also represented as q of m, as the variable in this polynomial is m. So this is how the polynomial is represented. We can have polynomials in some forms. The first of that is index form of a polynomial. Now to understand this one, let us consider one example, x raised to 4 plus 7x square minus 9. So suppose if we have to write this in index form, then first of all we have to write the terms of the given polynomial in the descending order of the power of the variable. So here the variable is x and the highest power is 4. So it should be x raised to 4 plus 7x square minus 9. So these are the terms which are already in the descending order of power of the variable x. Now if we have to write this in the index form, we have to collect the missing terms also. So as we can see here, the term with power 4 is there, but the term with power 3 is not there. So it's missing. So in the index form, while writing the same equation in the index form, we should write here x raised to 4 plus, so the term with index 3 is missing, so we can write it as 0 into x cube, which will not make any difference because 0 into any number it will be 0, plus the next term is 7x square plus x term is also missing, so that is the term with index 1 is missing, so it can be also written as 0 into x, and lastly the minus constant term minus 9. So as you can see here, now all the terms are in the descending order of the power of the x, that is x raised to 4, then 0 x cube plus 7x square plus 0x minus 9. So this is called as the index form of the polynomial. Now there is another form of a polynomial, that is the coefficient form of a polynomial. So for that, again consider one polynomial. Now this time the variable is m. So 3m raised to 5 plus 4m cube minus 7m plus 2. So this is the polynomial given. Now to write its coefficient form, first we have to write this in the index form. So we will write this in the index form. So to write this in index form, we have to collect all the terms according to the descending order of the powers of the variable m. So the highest power is 5, so first term should be 3 into m raised to 5 plus the term which contains the power 4 is missing here, so we should write 0 m raised to 4 plus cube term is there, 4m cube plus square term is missing, so it should be 0 m square minus 7m is there, and lastly the constant term. So this is the index form, as we have written all the terms in the descending order of the power of the variable m, that is 3m raised to 5, then 4, 3, 2, 1 and the constant term. Now if we have to write this in the coefficient form, in this coefficient form we have to collect just coefficients of each of the term the polynomial contain in a bracket. So the first term the coefficient is 3, comma, for the second term coefficient is 0, then for third term coefficient is 4, then for the next 0, then minus 7 and 2, bracket complete. So this is the coefficient form of the given polynomial which is in the index form. Now let us solve some examples based on these concepts. The first question is, state whether the given algebraic expressions are polynomials. Now, there is a condition or the criteria to be a polynomial is that the degree of the variable that is there in that algebraic expression must be a whole number, and if it is so, then that algebraic expression is a polynomial. So the first problem is y plus 1 by y. Here we have two terms. The first term is y and second is 1 by y. For the first term, the power of the variable y is 1. For the second one, the power of the variable y is minus 1. And we have the criteria for an algebraic expression to be a polynomial is that the power of the variable it contains, it must be whole number. And as we have seen here, for the second term, degree is a minus 1 and minus 1 is not a whole number. That's why the given algebraic expression cannot be a polynomial. So this is not a polynomial. In the second algebraic expression, the variable is x, and as x is under root sign, the degree of the variable x is 1 by 2. So again here 1 by 2 is not a whole number, and that's why the given algebraic expression is not a polynomial. Now the third algebraic expression is x square plus 7x plus 9. So here the variable is x, and as you can see, for all of the terms x square and 7x, the power of the variable x are whole numbers. That's why the given algebraic expression is a polynomial. Next is 10. So 10 is a constant number, and we know that a constant number is a constant polynomial. Therefore, the given number or the given constant number is a constant polynomial. So for this one also it is a polynomial. The next question is, write the degree of the polynomial given below. So the first is root 5. So as we know that here root 5 is a constant number, so which is a constant polynomial. So any polynomial which is a constant polynomial, degree of that polynomial is always 0. Now why is that so? Because suppose if we have a constant number or the real number root 5, it can be written as root 5 into, we can take any variable raised to 0, and as any variable raised to 0 or any number raised to 0 is always 1, which is same as root 5 into 1, that is root 5. So any constant number can be written in this form, and that's why the degree of any constant number is 0. And we should not say that as root 5 is there, so it can be written as root 5 is equal to 5 raised to 1 by 2. So that's why degree of this polynomial is 1 by 2. That's not the point, because root 5 is a constant number, and while finding the degree of any polynomial, we are considering the degree of the variable it contains. So as constant term do not contain any variable, that's why degree of that polynomial or the constant polynomial is 0. Now the second is x square. So it is very straightforward. The variable in this polynomial is x and its degree is 2. So degree of the given polynomial is 2. Third polynomial is root 2m raised to 10 minus 7. Now while finding the degree of any polynomial, we have to find the highest power of the variable it contains. So for this one, variable is m and the highest power is 10. That's why degree of this polynomial is 10. There is another problem, that is 7y minus y cube plus y raised to 5. Now here we have three terms, 7y, y cube is the second term, and y raised to 5 is the third term. So amongst these three, as we can see here, 5 is the highest power of the variable y. That's why degree of this polynomial is 5. So here degree is 5. So this is how we can solve examples for the finding the degree of the given polynomials. Now we have the next question. classify the following polynomials as linear, quadratic or cubic polynomials. So as we have studied, there are three types of polynomials if we consider the degree of the polynomial, that is linear, quadratic and cubic. So linear polynomial is the polynomial whose degree is 1. If there is degree 2, then that is called as a quadratic polynomial, and if the degree is 3, it is called as the cubic polynomial. So the first polynomial given here is 2x square plus 3x plus 1. So as we can see here, the degree of this polynomial, that is the highest power of the variable x, is 2, and as the degree is 2, it is a quadratic polynomial. The first polynomial is a quadratic polynomial. Consider the second one. So it has only one term, that is 5p. P is the variable and its degree is not given, that is its power is not given, that is it is 1. So if 1 is the degree of the polynomial, it is linear polynomial. So the second polynomial is a linear polynomial. Next is root 2 into y minus 1 by 2. Again here root 2 and 1 by 2 are the numbers given. So we are going to do nothing with that. Only we are considering the power of the variable it contains, that is the highest power of the variable it contains. So variable is y and its only power is 1. So if 1 is the power, it is linear polynomial. So again this one is a linear polynomial. We have next polynomial m cube plus 7m square plus 5 by 2 into m minus root 7. So as it has 4 terms, and amongst all these 4 terms, the highest power is 3. And if 3 is the degree of this polynomial, the polynomial is cubic polynomial. So this one is a cubic polynomial. Again, next polynomial is a square. So only one term is involved here, and the degree of this polynomial is 2. That's why this is again a quadratic polynomial. Now the next is 3t square. So for this one also only variable is t and its highest power, that is the single power, is 2. That's why its degree is 2. That's why again it is a quadratic polynomial. Now the next question is there. Write the polynomial in x using the given information. So we have to use the variable x and we have to write a polynomial for the given information. The first problem is we have to write a monomial with degree 7. So here we have to take the variable x. So let the variable x and we have to take its degree as 7, and we want a monomial. So that's it, x raised to 7. We cannot add or we cannot subtract because we need a monomial. We can write here 2x raised to 7, so which will be a coefficient of that monomial. So this is how we can have the monomial with degree 7. Now next problem is binomial with degree 35. So we need a binomial, we have to have the variable x. So we'll take x and the degree should be 35. So x raised to 35. Coefficient may be there. Here we need a binomial. That means we need another term plus. We can take now any of the term like 6x raised to 31 or 6x raised to 30 or 6x square, whatever it may be. Only one care should be taken that the second term that we are going to take, the power of that must not be greater than 35. We need a degree of polynomial 35. That's why the second term, in the second term, the power of the variable x must be less than 35. Now we have another problem, trinomial with degree 8. So the variable is x, we'll take its power 8. Now here we need a trinomial, that means we need another 2 terms. So we should take minus 7x raised to 6 plus 11x raised to 5. Now as we need a trinomial with degree 8, and in the first term we have taken the power of variable x as 8. So for remaining 2 terms, the power must not be greater than 8. So that's why we have taken here the powers 6 and 5 respectively. So that should be a proper trinomial as per the given information. Consider the next question. Write the following polynomials in standard form. First is m cube plus 3 plus 5m. So to write this in a standard form, we have to write the terms according to the descending order of the power of the variable, that is m. So the highest power is 3, so that term should be the firstly we should write m cube plus, now square term should be there, but in the given polynomial square term is not there, so we should write 0m square plus, now we need a term with power 1, so that is 5m, so 5m, and lastly the constant term, that is 3. Write the following polynomials in coefficient form. So the first is x cube minus 2. So to write its coefficient form, we should first write this in the standard form. So the standard form will be x cube plus, now square term is not there, so we should write 0x square plus x term is also not there, so it should be 0x, and lastly the constant term, that is minus 2. Now we can write this in coefficient form. To write this in coefficient form, we have to collect the coefficient. For the first term, coefficient is not given, that is 1, comma, coefficient of second term is 0, third term is 0, and lastly the constant term is minus 2. So we should take the coefficients along with their signs. So this is the coefficient form of the given polynomial. We have another problem. 2m raised to 4 minus 3m square plus 7. Again we have to write this in standard form. So the highest power is m raised to 4, that is 2m raised to 4 plus, now cube term is not given, so we should write 0m cube minus square term is there, 3m square plus the constant term is 7. So to write this in coefficient form, we have to just collect the coefficients of each term, that is for the first term coefficient is 2, for the second term it is 0, then minus 3, and the constant term is 7. So this is how we can convert the given polynomial into a coefficient form. Now the next question. Write the polynomials in standard form. So the first polynomial given is 1, 2, 3. So first of all we have to find the degree of the polynomial that we want. So as there are 3 terms in this coefficient form, the last term is the constant term. So apart from the constant term, there are 2 more terms remaining. So that will be the degree of the given polynomial. So here as 3 terms are there, out of which 3, the last term is a constant term. So degree of this polynomial is 2. Now if degree is 2, we have to write it is this is the coefficient form. That's why 1 is the coefficient of the first term whose power is 2, as degree of the polynomial is 2. So we should have 1 into x square. Here we use x as a variable. Now for the second one, the coefficient is 2, that is plus 2. So plus 2 into, we have to write in the descending order of the power of the variable x. So after x square we should have x, that is 2 into x, plus lastly the constant term 3. So which can be also written as x square plus 2x plus 3. So this is the standard form of the given polynomial which is in the coefficient form. We have another problem. 5, 0, 0, 0, minus 1. So again, as we can see here, in all 5 coefficients are given there, out of which the last one is the constant. So the remaining terms are 4. So degree of that polynomial is 4. Now we have to write this in standard form. So 5 is the coefficient. The degree of the polynomial is 4. That's why if we take the variable y here, so degree will be y raised to 4. So 5 y raised to 4 plus the coefficient, second coefficient is 0, 0 into y raised to 3. Now we have to go on writing according to the descending order of the power of the variable y, plus again the coefficient is 0 y square plus 0 y, and the last is minus 1 is the constant term, it is minus 1. So this is the standard form of the given polynomial. I hope you understand the topic. Thanks for watching.